Hello everybody, in this video we are going to continue our fraction unit with adding and subtracting fractions that have algebraic expressions in them. So when we're adding and subtracting fractions with algebraic expressions, we're going to follow the exact same steps we did when adding and subtracting numerical fractions. So let's just do a quick review on the steps that we used when solving adding and subtracting fractions. So again, particularly paying attention right now to the steps that we used. So the first step is that we've noticed that the bottom numbers are different and we want them to have a common denominator. So I'm looking at the 5 and the 3 and I'm trying to think of what number can I get both of those numbers to. I could make a list, find the lowest common multiple. And what I can notice is that I want them to be out of 15. So I'm going to write each of those fractions out of 15 and add them together out of 15 instead. So 5 to get to 15 is times 3. 4 times 3 is 12. 3 to get to 15 is times 5. So I'm going to do 2 times 5 is 10. So I'm adding together 12 out of 15 plus 10 out of 15. So my first step was to find a common denominator. Okay. Then I'm going to add the tops and I get 12 plus 10 out of 15. So I get 22 out of 15. So I'm going to simplify that to 1 7/15. So my final step there was to simplify. So I find a common denominator, I add or subtract the top, and then I simplify. Let's follow that same procedure here for this next question. I have a 5 and a 10, so I'm going to make them both out of 10. 5 to get to 10 is times 2. 4 times 2 is 8. And 7 out of 10 is already out of 10. So I get 8 out of 10 minus 7 out of 10, which is 1/10. And that's as simple as I can make it. So again, our steps here was finding a common denominator, adding and subtract the tops, and then simplify if needed. We're going to follow those same steps now with algebraic expressions. So here I have 4 over 5a squared plus 2 over 3a. So I have a 5a squared and a 3a. Let's just ignore the letter for a minute and just look at the 5 and 3. So what I'm thinking about as the lowest common multiple between 5 and 3 is 15. So the number on the bottom of my fraction is going to be 15. Now if we look at the algebraic side, I have a squared and a. Well, the common denominator or lowest common multiple between those is going to be a squared because the multiples of letters are their exponents. So we can have a squared, a cubed, a to the power of 4, and so on and so on. Those are the multiples, if you think of it, of our letters. So the lowest common multiple between a squared and a is a squared. I can multiply a by a in order to get a squared. So that means I want the bottom of both of these fractions to be 15a squared. Okay, so let's look at 4 over 5a squared. What do I have to do to get it to be 15a squared? I'm going to times it by 3, right? So to get the 5 to 15, I'm timesing by 3. And the a squared's already an a squared, so I'm just going to times it by 3. If I times this top by 3, I get 12. So my first one is 12 over 15a squared. My next fraction is 2 over 3a, and I want to get that to be 15a squared. So again, let's just first look at the number. To get from 3 to 15, I times by 5. And to get from a to a squared, I times by a. So that means I need to times by 5a all together to get 3a to 15a squared. So if I times 2 times 5a, I get 10a. Okay, so it's the same process. I'm finding a common denominator. So I looked at my number first, 5 and 3 to get to 15. And I look at my letter, a and a squared can both become a squared. Then I look at how do I get 4 over 5a squared to be something out of 15a squared, and 2 over 3a to be something out of 15a squared. Again, if you think of the number and the letter sort of separately and then put them back together, that can really help simplify it. So now I'm going to do 12 over 15a squared plus 10a over 15a squared in order to get my answer. I'm going to add the tops. And I get 12 plus 10a over 15a squared. Now I can't simplify this anymore because I cannot combine the 12 and the 10a because the 12 doesn't have an a next to it. So if you think of collecting like terms, I can't combine a 12 and something with a letter. You can only combine ones together that have the exact same letter term. Okay, so this is as simple as I can do it. I also don't have a number that's common between 12, 10, and 15. So there's no number I can divide each of those by in order to simplify it. So this is as simple as I can make it. Let's look at this one here. So I have a 5x squared and a 10x. So just looking at the numbers 5 and 10, the lowest common multiple is going to be 10. Now looking at the letters, I have an x squared and an x. The common is going to be x squared, so I can make the x an x squared. So that means I want to make each of these a fraction out of 10x squared. So to take 4 over 5x squared and make it a fraction over 10x squared, I'm just going to multiply by 2 because the x squared is already there. So I get 8 over 10x squared. For 7 over 10x, I want to get it to 10x squared. I'm going to have to multiply by an x because I already have the 10, and to get from x to x squared, you multiply by x. So I get 7x on the top here. So now if I subtract the tops, like this, and that is as simple as I can bring it because there's no number that I can divide 8, 7, and 10 by, and I can't combine my 8 and 7x or subtract them. So that's as simple as I can go. Okay, now this one's added in some exponents. So before I can even worry about adding them, if you think of our order of operations, I have to do the exponent first. So I need to solve 4 over x squared first. This is like saying 4 over x times 4 over x, right? Because if you remember, if I had something like 3 squared, that's the same as doing 3 times 3. 3 to the power 4, that's the same as doing 3 times 3 times 3 times 3, right? So it's taking this base and multiplying it by itself, whatever the power is. So I'm taking my base, which in this case is 4 over x, and I'm multiplying it by itself 2 times. So I end up getting 4 times 4, which is 16, and x times x, which is x squared. So when you see something like this, what you're actually doing is doing 4 squared over x squared. So that squared applies to the top and the bottom, not just the top. Okay? So again, this becomes 16 over x squared. So now I have 16 over x squared plus 2 over 3x squared. I need to find a common denominator between x squared and 3x squared. Well, 1 and 3, the least common multiple is 3, and x squared is x squared. So that means I want both of these to be fractions over 3x squared. To get from x squared to 3x squared, I'm going to multiply by 3, and 16 times 3 is 48. 2 over 3x squared is already over 3x squared, so I'm just going to leave it. So this becomes 48 plus 2 over 3x squared. Now because both the 48 and 2 don't have a letter attached, I can combine these together, and I get 50 over 3x squared, which I can't simplify anymore. There's no number that goes into 3 and 50. And we're not going to write this like as a mixed number or anything like that. We're just going to leave it as 50 over 3x squared. Okay, one more here. Again, I have my brackets, and with an exponent, I'm going to do that first. Again, this is like saying minus 2 over a times negative 2 over a, which is 4 over a squared. Or again, you can take this minus 2 and square it over a squared. Now that negative is going to be attached to that 2. And so a negative times a negative is a positive over a squared. So just be really careful with that negative there. Because the negative is inside of the bracket, it is being applied, the square is applying to that as well, and a negative times a negative is a positive. Okay. So we end up getting 4 over a squared minus 3 over 4a squared. So I see I have an a squared and a 4a squared. So the common denominator there is going to be 4a squared. So I want to write them both as fractions over 4a squared. This last one is already 4 over 4a squared, so I'm going to leave it. To get from a squared to 4a squared, I'm going to times by 4. So I get 16 over 4a squared minus 3 over 4a squared. And so I get 13 over 4a squared. And again, that can't be simplified anymore because there's no number that goes into 13 and 4. Okay, so again, just to summarize, when you are adding and subtracting fractions that have algebraic expressions in them, you're following the exact same steps as you did when you were adding and subtracting regular fractions. And a key thing to keep in mind here that we added in is also these exponents being multiplied into a bracket with a fraction, and what that means, especially in terms of the negative.